Let us try to understand what is the law of gearing or condition for constant velocity ratio. So here we have shown that two teeth, they are in mesh with each other, or two gears which are in mesh with each other. So this is gear 1 and gear 2. Their respective centers are O1 and O2. Now this is the pitch point, the point at which the two pitch circles of this gear 1 and gear 2, they intersect each other at this particular point, that is point P, and this point P is known as the pitch point. Now let us assume that these two gear teeth, they are in contact with each other at this particular point, and let us call this point as K. Now draw a tangent passing through this particular point K. So T is the tangent passing through this point of contact of the two meeting gears. Similarly, draw a common normal passing through this point K, that is n dash is the common normal to this particular tangent passing through K, and it must also pass through this pitch point, that is P. Now draw a perpendicular, so O1M is perpendicular to this common normal, that is n dash. Similarly, O2N is also perpendicular to this common normal n dash. Now draw these velocity vectors v1 and v2. So v1 is perpendicular to this O1k, and this v2, it is perpendicular to this O2k. These velocities v1 and this velocity v2 will have the components along this common normal as well as along the common tangent. Now let us assume that this angle is alpha, that is NO1k, that angle is alpha, and NO2k, that angle is beta. Now omega 1 and omega 2, these are the velocities with which the gears, they are rotating. Now if this angle is alpha, this angle is also alpha. So V1 is making, the velocity V1 is making an angle of alpha with this common normal. Similarly, velocity V2 is making the angle beta with this common normal. Now this velocity V1 and V2 will have components along this common normal, that is n dash. So that is nothing but, suppose if we consider this as point K, and suppose we consider this as point K dash, correct? Then this velocity V1 will have component along this normal. Similarly, this V2 will also have the same component along this normal. So this is the perpendicular. So this V1 will have adjacent component, that is V1 cos alpha, that is K dash is V1 cos alpha. Similarly, this V2 will also have the component, correct? But that angle is nothing but beta, so it is V2 cos beta. So K dash is also equal to V2 cos beta. So just now we have seen that this component of velocity V1 along n dash is V1 cos alpha. Similarly, component of V2 along n dash is equal to V2 cos beta. Now to have the proper contact or proper rolling motion, we must have these two components to be equal. So we can say that V1 cos alpha must be equal to V2 cos beta. Now we know that V is equal to R into omega. So here R is nothing but the distance O1k, because this is the radius, correct, to which this vector V1 is perpendicular. So it is R is nothing but O1k over here, and omega 1 is the angular velocity of gear 1. Similarly, V2 is equal to O2k, because this V2 component is perpendicular to this O2k. So here this O2k will become the radius in our case. So R into omega 2, that is O2k into omega 2 into cos beta. Now from triangle O1MK, so this is O1MK, we can say that cos alpha is nothing but the adjacent side. So adjacent side is O1M and hypotenuse is O1K. Similarly, from the right angle triangle O2NK, we can say that cos beta is nothing but the adjacent side, that is O2N divided by the hypotenuse, that is O2K. Now we can substitute these values. So here we are having these values of cos alpha that can be substituted over here, and value of cos beta can be substituted over here. So in place of this cos alpha, we have substituted this value, and in place of this cos beta, the value that we have substituted is this one. Now cancel out this O1k from this side and O2k from the right hand side. So we are left with omega 1 into O1m is equal to omega 2 into O2n. In other words, we can say that this angular velocity ratio omega 1 upon omega 2 is equal to O2n divided by O1m. From the similar triangles O1MP and this O2NP, we can say that O2n divided by O2P must be equal to O1m divided by O1P. In other words, we can say that O2n divided by this O1m is equal to O2p divided by O1p. Or we know that this O2n divided by O1p is nothing but what? It is omega 1 upon omega 2. So omega 1 upon omega 2 is equal to O2p divided by O1p. In other words, we can say that in order to have these constant angular velocity ratios for all positions of the mating gears, the point P must be a fixed point, and that point P is known as the pitch point. In other words, we can say that the common normal at the point of contact, so point of contact is K and common normal is n dash n dash. So the common normal at this point of contact K between the pair of this particular gear teeth must always pass through a pitch point that is shown over here. So this is the fundamental condition for the law of gearing.